Okay, so today we're going to be talking about parallel lines and the relationships that they make when paired with transversals. So the first thing we're going to do is we're going to create a set of parallel lines that run through specific points. So we have point A and point B. And first thing you're going to want to do is create a line that runs through point A and point B. And so we've created line AB. And now next, you're going to want to take your compass and you are going to want to set it so that it is on point A. And next, once you get your compass out, you're going to extend it. And it doesn't really matter what distance you extend it, just so long as the arc that you're making, it crosses both line A and line AB and is before the cross that it creates is before point B. Now you're going to keep your compass at the same distance, and you're going to create this same arc again up on point B. And so you're going to want to make sure that your compass is set to the same distance, and then you're just going to create the same arc. The next thing you're going to want to do is bring your compass down to the cross that you've made, the first cross, and you're going to set it there, and then you're going to bring it down to the intersection of line A and make an arc, and then you're going to create that with your compass at the same distance. You are going to create that same arc on the upper side with your second cross that you've made, and you are going to you'll have the second arc made, and this allows you to know your points that you are going to make your line on. And so then you're going to create your line, and it's going to run through point B and the second point that you've made here, and that's how you make a parallel line. Okay, so now that we've created our parallel lines, we're going to prove that they are indeed parallel. So what we're going to do is we're going to measure an angle on line B, and there you can see it's 128.66 degrees. Now we're going to measure the corresponding angle on line A, and as you can see, that line will also be 128.66 degrees, which proves that these lines are indeed parallel. Okay, so now I'm just going to take a minute to clean up my work and delete some of these extra arcs and points. That way it's easier for me to show the relationships between parallel lines. So as you can see, now I'm just creating the measurements for all of these angles. That way it's easy to identify that the relationships that I'm going to be showing you are really there, and that way you can tell that it's actually happening and see the measurement. Okay, so now that we've cleaned up our angles and our work, and we've measured it all out, I'm going to take a minute and label all these angles real quick. That way it's easy and clear what we're discussing when we talk about our relationships. Okay, so now we're going to talk about supplementary angles. This is the first relationship I want to discuss. And a supplementary angle is an angle that sum equals 180 degrees. So if you were to take two angles and add them up, it would equal 180 degrees. That's a supplementary angle. So angles 1 and 2 are supplementary angles because 128.66 plus 51.34 equals 180 degrees. So therefore angles 3 and 4, 5 and 6, 8 and 7 are also all supplementary angles, and as are 2 and 4, 6 and 7, 5 and 8, and 1 and 3. Complementary angles are angles that sum equals 90 degrees. So we don't have any perpendicular lines in this drawing, so I'm going to create one quickly to use just for this demonstration. And as you can see, once this line is created, angle 2 plus the angle that is created in the line that intersects with line B and point B, that is 90 degrees. So those two angles are complementary, as are angles 3 and the other angle that is created in this drawing. And that's complementary angles in their most basic form. Adjacent angles are two angles that share a vertex and on the side. So adjacent angles in this drawing would be angle 1 and angle 2, as they share the vertex B and the side of line AB. Other adjacent angles would be 2 and 4, 4 and 3, 1 and 3, 6 and 7, 7 and 8, and 5 and 8, along with 5 and 6. So those are all the adjacent angles in this drawing. Next is corresponding angles. Corresponding angles are one of the most basic relationships that parallel lines and transversals create. It's where you have two angles that have the same measure that are in corresponding places, like 1 and 5, 3 and 8, 4 and 7, and 2 and 6. Alternate interior angles are angles that are on alternate sides of the transversal and on the insides of both parallel lines, so inside of line B and line A. And they have the same measure, so in this case we would have angles 4 and 5 and angles 3 and 6 as alternate interior angles. Okay, so next up is alternate exterior angles, which is basically the same thing. You have angles on opposite sides of the transversal, but this time they are on the exterior of the parallel lines, so that would be on the outside of line A and line B. So alternate exterior angles in this drawing would be angle 8 and angle 2, and then the other pair would be angle 1 and angle 7. Same side interior angles are our next relationship, and they are very similar to alternate interior angles, except that they are on the same side of the transversal and therefore would have different angle measurements. So in this case we have angle 4 and 6 as one pair and angle 3 and 5 as the other same side interior angle pair. The last relationship we're going to talk about are vertical angles. This is another very basic relationship that we have when parallel lines are crossed by a transversal. It is when two angles share a vertex but no other sides, and they have the same measurement. So we'd have 1 and 4, 2 and 3, 6 and 8, and 5 and 7 as our vertical angle pairs.